Greetings everybody, and welcome to our next problem in cross products. So what we're given here are three vectors u, v, and w, and we're asked the simple question, are u, v, and w coplanar? Well, geometrically, kind of what's going on there is if we had three vectors and they were not coplanar, so if we had a vector u, we had a vector v, and we had a vector w, and if those things were not contained in the same plane, then essentially what we would be able to do is to draw a parallel pipe which would actually have a volume to it. And so that three-dimensional shape would have a volume. And so one thing that we can kind of conclude is that if we calculate the volume of the parallel pipe formed by u, v, and w, that if that's 0, then we don't really have a volume, and the implication being that those vectors are going to be all in the same plane, or they will actually be coplanar. And so kind of the question, or how we would solve this problem, then is basically this. So u, v, and w are coplanar when we do the volume of the parallel piped, or in particular, the scalar triple product, and that volume ends up being 0. And so that's what we have to do in this particular case. We compute the scalar triple product to see if we get a value of 0. So doing just that, if we have u dotted with a v cross w, then we are computing the 3 by 3 determinant, where our first row is going to be u, so -1, -7, -4. Our second row will be v, so that will be 2, 3, and 0. And finally, our third row will be w, or 0, 11, and 8. Computing this, what we have is our first entry in our first row being -1 times the 2 by 2 determinant we have when we get rid of the first row, get rid of the first column. So we have 3, 0, 11, and 8. Then we change the sign, so we have a negative of our second entry, a -7, times our determinant, where we get rid of the first row, second column, which would give us a 2, 0, 0, and 8. And finally, for our third entry, we have -4 times our determinant of getting rid of the first row and the third column, which is 2, 3, 0, and 11. And so what that gives us then is a -1 times a 3 times 8, which gives us a 24, minus 11 times 0 is 0, minus a -7, so it's plus 7, times our determinant, 2 times 8 is 16, minus 0 times 0, and then minus 4 times our determinant, 2 times 11, which is 22, minus 3 times 0, which gives us 0. And so we have a value of -24 plus a value of 7 times 16, or 112, and then minus a 4 times 22, which gives us an 88. Well, when we add these together, sure enough, we do end up with a value of 0, and so, yes, the vectors are coplanar. And so what we found our answer. So I hope you've enjoyed this problem, and I will see you guys in the next one. Take care.